Good morning, children. This is chapter Light, lecture 1. In this chapter, we will study about the refraction of light. Here are some observations given. These observations we are experiencing in our day-to-day life. The first one, a coin immersed in a water-filled beaker appears to have been elevated from the bottom. It is looking like this. The second one, a pencil dipped in a water-filled glass appears to have been bent from the surface of the water. It is looking like this. You can do this. You can experimentally, you can see that. Okay, it is looking like that. The pencil is bending. The third one, after a brief shower, when the sun comes up, again a rainbow is seen in the sky. And a fisherman sees the elevated image of the fish inside the water and aims his lens accordingly. Why all these things are happening? Why the coin appears to have been elevated from the bottom? Why the pencil appears bending? All these things, all these observations are due to a phenomenon of light which is known as refraction. So in this chapter, we will study the property of light, that is refraction. Light is having the property of reflection, refraction, and many other properties the light is having. Here in this chapter, we will study about the refraction. Now the main question is coming, what is refraction? Normally, light moves in a straight line. However, it has different velocities in different media. That means suppose the light is passing through glass, it is passing with a particular velocity. If it is passing through water, it will pass with a particular velocity. If it will pass through gas, it will pass with a particular velocity, like that. Okay, so it has a different velocities in different media. Different velocities in different media. When light enters a second medium from the first, suppose I am having this type. The light is entering from air. Suppose this is air medium, and here we have taken water. So suppose a light ray is coming from here. It is entering in the water medium. So the first medium is air and the second medium is water. So when the light is coming from the first medium and it is entering to a different medium, then because of their different densities of the medium, the light changes its velocity. Its speed changes. Okay. Now, when light enters the second medium from the first, both with different densities, its speed changes. I think you have understood. The light wants to accommodate this change in speed by changing its course, or in the other words, its path changes and the ray bends. This phenomenon is called refraction. Okay, so the bending of light from when it is passing from one medium to another medium, because of the different densities of different medium, the light changes its path, and this phenomenon is known as refraction. For example, the speed of the light in air is 3 into 10 to the power 8 meter per second. In glass, it is 1.8 into 10 to the power 8 meter per second. When light travels from air to glass, it accommodates the change in speed light rays bend, and this is called refraction. Terms related to refraction. The first one is incident ray. The ray XO, which falls on the boundary AB, is called the incident ray. Now, what is boundary? See, we have taken two medium. One is air medium, another is glass medium. Air is the rarer medium and glass is the denser medium. Okay. Now, which line is differentiate the two media, that is air and glass? This AB, this interface, is known as boundary, AB. Now the ray XO, which is falling on the boundary, it is coming from air medium. You can see here the arrowhead is in this side. It is coming from air and it is entering to glass. So this ray is known as incident ray. Refracted ray, when the ray XO enters the denser medium, as I told you, glass is the denser medium. When the ray XO enters the denser medium, it gets deviated from its original path. This is, you can see this is deviated and it is going out in this way. The arrow is giving in this way. Okay, and it bends. Thus, the ray OY, we have given the name, it is OY. You can see here, this is OY, is called refracted ray. Point of incidence, the point O, this point, the point O on the boundary AB, from where the incident ray enters the second medium, is called the point of incidence. The incident ray XO is falling from air medium to the boundary AB, and from this O point it is just entering the glass medium. This point is known as point of incidence. Next is coming normal. The line NP. The line NP, you can see here this line is NP. See that? This is NP line. The line NP is perpendicular to the boundary AB. You can see here, this is the boundary AB and this is your NP line. This is the boundary AB and this is your N and P line. So that means NP, line NP is a perpendicular to the boundary AB and is passing through the point of incidence O. This is the point of incidence O. It is passing from here. This is called normal. So this line is normal. Next is angle of incidence. Now what is angle of incidence? Angle of incidence, the angle between the incident ray and the normal. The angle between the incident ray and the normal is known as angle of incidence. So here XON, just see here XON. XON is the angle between the incident ray and the normal. This angle is known as angle of incidence and it is denoted by I. It is denoted by I. Angle of refraction, the angle between the normal and the refracted ray is known as angle of refraction. Now see here, the refracted ray is OY. OY is the refracted ray. So the angle between OY and OP, this is also the normal. You can see OP is the normal, the boundary AB. So the angle between the refracted ray and the normal, so the angle is coming angle YOP. Okay, this angle is known as angle of refraction and it is denoted by R. And XON is the angle of incidence and it is denoted by I. Is it okay? Laws of refraction. Whenever a light ray suffers refraction at the boundary of the two optically different media, we were talking about air and glass, so these are the two optically different media. It obeys the following laws. The first law states that the incident ray, the normal to the point of incidence, and the refracted ray all lie in the same plane. That means incident ray and the normal and the refracted ray all lie in the same plane. And the second law is based on the pair of media through which the light undergoes refraction. It is depending upon the pair of media. What it is said? It states that from here, it states that the ratio of the sine of angle of incidence to the sine of angle of refraction is always a constant. Now what is sine of angle? It is a trigonometrical ratio of an angle. Now when you will go to the higher class, then you will study about all these things. Now here you just know it is a sine of angle of incidence and the sine of angle of refraction. This is having a particular value. If you will find this two, sine of angle of incidence by sine of angle of refraction, it will give you a constant. And that particular constant is known as refractive index. And what is that? Refractive index of the second medium with respect to the first. This is very important to know. The refractive index of the second medium with respect to the first. And this law was given by Snell and hence it is popularly known as Snell's law. This you have to know, this law is known as Snell's law. Sin I by sin R is equals to constant. These are the two laws of refraction which are very, very important. You have to learn these two laws. So now what is refractive index? Refractive index of a medium is the ratio of the speed of the light in vacuum to the speed of the light in that particular medium. So it is refractive index is denoted by this letter which is known as mu. Mu is equals to speed of the light in vacuum or air, whatever it may be, divided by speed of the light in medium, in a particular medium. Snell's law may now be expressed as mu is equals to sin I by sin R. Clear? So refractive index of some media is given with respect to vacuum. That means vacuum will be at the top and second is the medium. Air, the refractive index is 1.0003. Water 1.33, alcohol 1.36, glass 1.5 and diamond it is 2.42. This diamond, glass, air, this you have to learn a little bit. Okay. So here one numerical given. What is the speed of light in a medium whose refractive index is given 4/3? That means mu is given. If the speed of light in air is 3 × 10⁸ meter per second. So you know that the speed of the light in air is given and you know the refractive index. Your formula is mu is equal to speed of the light in air by speed of the light in medium. Now from here the speed of the light in medium will be speed of the light in air by mu Okay, now put the value speed of the light, that is 3 into 10 to the power 8 meter per second, and the value of mu is given 4 by 3. Right here 4 by 3. After calculation you will get 2.25 into 10 to the power 8. Okay, that means what we are doing? 3 into 3 by 4, and we are keeping 10 to the power 8 as it is. Now solve this. 9 by 4. It is coming 2.25, and 10 to the power 8 will be written as it is. It is written as it is. So it is this much meter per second. So speed of the light in the particular medium is 2.25 into 10 to the power 8 meter per second. I hope I am clear to you. Now, some unique properties of refraction. The first one, when a ray of light enters a denser medium from a rarer medium. From a rarer medium, the ray of light is entering to the denser medium. That means what we have discussed from air, it is coming from air and it is entering to glass. That means it is entering from rarer to denser medium. Very important, it always bends towards the normal. Just see here. This is air and glass. Now the incident ray is coming here. It is bending towards the normal. It is bending, otherwise it should go straight. This is the line. It should go in this line, but it is not going in this line, this dotted line. It is bending towards the normal. Here, that means angle of I, angle of incidence, is greater than angle of refraction. Okay. Second is, when a ray of light enters a rarer medium, now the just opposite. It is entering from denser to rarer medium. See here. Now see this one, this figure. Now it is entering from glass. See the arrow. Arrow is in this side. So it is entering from glass and it is going to air medium. Okay. So when a ray of light enters a rarer medium from a denser medium, it always bends away from the normal. You can see that it is going through this line. Otherwise, it should go straight, this dotted line, but it is not going in this way. It is bending away from the normal. In this case, the angle of incidence is less than angle of refraction. Okay? So that the angle of refraction will be more than the angle of incidence, what I told you just now. And the third one, a ray of light traveling along the normal does not suffer any bending. That means what? Suppose my medium is air and glass. The ray of light is incidenting through this normal in this line only. Okay, see, this is the normal line. In this line only it is entering through this line. See the arrow. Now it will not suffer any bending. It will go straight. Okay, in that case, what is angle of incidence? Angle of incidence is the angle of incident ray, angle between the incident ray and the normal. And what is the angle of refraction? It is the refracted ray and the angle between the refracted ray and the normal. So this incident ray is traveling along the normal only. That means your incident angle and the refracted angle both will be 0. Okay, have you understood? That means the angle between the refracted ray and the normal is 0. Angle between the incident ray and the normal is 0. So what we are getting? For the first case, angle I is greater than angle R. For the second case, angle I is less than angle R. And in the third case, angle I is equals to angle R is equals to 0. 0. Okay? Am I clear? Don't get confused. It will not be 90 degree. The angle of incidence is the incident ray, the angle between the incident ray and the normal. So it is traveling along the normal. So its angle of incidence will be 0. And it does not suffer any bending. So it is going in the same path. It is following the same path. So angle of refraction is also 0. And angle of incidence is equal to angle of refraction. Effects of refraction. See the figure here. This diagram you have seen in slide number 2, observation 2, that is bending of a pencil. Now here you can see that one pencil is immersed in a glass which is filled with water. A ray of light coming from the tip of the pencil X and travels from water to air before reaching the eye. Now you can see that this is the water medium and this is your air medium and this is the interface. Okay, now you can see that two rays we have taken here. See, from one point n number of rays can come out, but here we have taken only 2, and without 2 actually you cannot make the image. That is why 2 is necessary. 2 you have to take. So the 2 rays are coming from the tip of the pencil, that is from point X, and it is touching this interface. Suppose it is AB, and then as it is going from water to air, water is a denser medium and air is the rarer medium. So it is going from denser to rarer medium. So it will bend away from the normal. See, here will be the normal. Two normals will be here. One in this point, another is in this point. So they are bending away from the normal. And then they are reaching to the eyes. Now, this refracted ray, this one and this one, these two produced backward. See with the dotted line, and you can see that the pencil, it is meeting in this point, and this point is X dash, this point. Just let me show you with a different color. This is this point, this point. Okay, now this point is denoted by X dash. Now X dash is above X, which is the image, which is actually it will, the pencil also appears to beam, the pencil somewhat appears to be above the bottom surface, okay, of the glass, and the pencil appears to bend, appears to be bent. Am I clear? The other observations in the second slide that we have given, that the coin one and the rainbow slide, may also be explained in the similar manner. Okay. Next is refraction of a light through a parallel slided glass slab. See, this is a glass slab. A, B, C, D is the glass slab in which AB side is parallel to DC side. It is a thick glass slab. Okay. Now, this is the air phase and this is your glass phase. Correct? Now, For studying refraction of light through a glass slab would require a rectangular glass slab, board pins, pencil, sheet of paper, drawing board, scale and protector. Okay. Now, how we are doing it, what actually happening, you can see that the ray of light is coming from here, that is PO line is the incident one. Then it is inside the glass, it is going from O to O dash. Okay, this is your refracted ray. That is inside the glass, it is going because the glass slab it is little thicker, thick one. And this is coming from air to glass medium. So naturally it is coming from rarer to denser medium. So it will bend towards the normal. And then again this line O dash is again incidenting on the surface DC. Now from here again it is going out. That means it is air medium. So this for this DC line, this O dash is the incident line, and O dash, let us suppose here, let me give some name, X. So O dash X is the emergent line. It is known as emergent ray. Okay, now it is again coming from glass to air, that means denser to rarer, so it will bend away from the normal. So this ray is coming here. Now all these things, step by step activity, what we are doing, everything will be discussed in the class when I will take the doubt clearing class of this chapter. Okay. Refraction of light through a prism. A prism is an optically transparent device made up of glass having triangular bases and rectangular sides. Now see that this is a prism, this is a figure of a prism. In this is and this is, these two are the rectangular sides. You can see that these are the rectangular sides, and these rectangular surfaces are also called the refracting surfaces. Okay, from here and here, they are the refracting surfaces. And this is the base. Okay, triangular base. It's having a triangular base and a rectangular, two rectangular sides. Now, the rectangular surfaces are called refracting surface, and the angle between these two refracting surfaces, that means this angle, is known as angle of prism. Now refraction of light through a prism. Now refraction of light through a prism takes place in the following manner. See, for showing the picture, we are taking only one surface like this, triangular surface, for denoting the prism. We are taking like this. Now in that you see a ray of light, this one MO is the incident ray. See here, the arrow is showing incident ray. It is incidenting in the surface AB. Okay. Now this side is my air medium and this is the glass medium. Okay, so MO is incidenting on the surface AB. Okay, so this MO is known as incident ray. Now inside the prism, now see, this is the normal R and R dash is the normal for the side AB. If you put a protector and put 90 degree, you will get R dash as the normal. Okay. Now it is the ray of light. Now it is coming from air and entering to glass. That means it is coming from rarer medium and it is entering to denser medium. So naturally it will bend towards the normal. You see, this is the normal, this line is the normal. Okay, let me just show you. This line is the normal. Now you see that the ray of light MO should pass with the dotted line, this one, but it is not going to that way. It is just bending towards the normal, this line. Okay, now this is shown with an arrow. This is O dash. Now this O dash is known as refracted ray. Okay, now this O dash is incidenting again in the phase AC. This is your C. It is incidenting in the phase AC. Okay, now the refracted ray is becoming incident ray for the phase AC. Okay, now again this O dash ray will pass from glass. It is coming out and it is going through air. This is again air. Okay, so it is coming from denser medium and it is going to rarer medium. This is glass. So you see that O dash is incidenting in the phase AC. This is C, I told you. Just 1 minute. This is C. So in phase AC, this O dash is incidenting. Now it is incidenting from glass and it is going out to air medium. That means it is now coming from denser medium and going to rarer medium. So naturally this P dash, this is P and this is P dash. This is the normal. If you put a protector and if you draw a 90 degree, you will get this is the normal. Now, as it is coming from denser to rarer medium, it will go away from the normal. So, this is the line I am getting, ON. Okay, so this O dash N is known as emergent ray. Clear? Now, this is your angle I. This is your angle I. This is angle of incidence. R1, this angle R1 is known as angle of refraction at the first face of the prism. R2, now R2 is the angle, this one is R2. R2 is the angle of refraction at the second phase of the prism. Okay. Angle E is known as angle of emergence. Angle D is the angle of deviation. Now suppose if you are extending this O dash in line in the backward direction and OM ray in the forward direction, where these two rays are meeting, this point, the angle between this is known as angle of deviation, delta. This is known as delta. Okay, or D. A is the angle of prism, this one is the angle of prism, and R dash, as I told you, it's a normal to the face AB, and P dash is a normal to the face AC. For studying the refraction of light through a prism, one needs a triangular prism, sheet of white paper, drawing board, board pins, pencil, scale and protector. This I will tell you step-by-step activity that will be discussed and explained in the doubt clearing class. Next is dispersion of light. When a white light is allowed to pass through a prism, it splits the white light into 7 colors. This is very important. Now, when a white light is allowed to, you know that white light is a combination of 7 colors. Okay, now when a white light is passed through a prism, then it splits the white light into 7 different colors. You can see here. That is the VIII. Okay, violet, indigo, blue, green, orange, yellow and red. That is VIII. This band of color is called spectrum. Very, very important. And the process of splitting the white light into its constituent color is called dispersion. You have to learn all these things, children. Now, for demonstrating the dispersion of light through a prism, one needs a triangular prism, cardboard sheet and a wide drawing sheet. And a step-by-step activity will be described in the doubt clearing class. Again, how we are getting the 7 colors, band of 7 colors, which is known as spectrum, that will be discussed in the class. For studying the condition of dispersion of light, one needs 2 identical triangular prism. One is this one, another is this one. And a wide drawing sheet. And what is happening? How it is happening? First of all, it is dispersed into 7 colors. Again, when it is going through a just inverted prism, then we are getting a white light again. How it is happening? First it is dispersion and then it is again recombination. That everything will be discussed in the doubt clearing class. Formation of rainbow. Sunlight is composed of 7 major colors. Water droplets in the atmosphere acts as tiny prism. Water droplets in the atmosphere acts as tiny prisms. Also, water droplets have higher density than air. Okay. Now, as a result of this, when sunlight enters the water droplets, it gets dispersed into its constituent colors as per the speed of the particular color of light in a denser medium. All of them do not come out of the droplets at the same time. Now this causes splitting of sunlight and we view it in an arc. Okay, which is popularly called rainbow. Please read this and try to understand. Water droplets are present in the atmosphere. This acts as a tiny prism and water droplets have higher density than air. So when the sun rays are entering that water droplets, as water droplets acts as a prism, it disperses into its constituent colors. But with the speed of a particular color of the light in a denser medium. All the particular color of the light is having a particular speed. Okay. All of them do not come out of the water droplets at the same time. Okay. It is entering into the water droplets and then again it is coming out. So all of them are not coming out at the same time. This causes the splitting of sunlight and we view it as an arc. That is known as rainbow. Now the video for the lecture 1 ends here. In the next video, we shall study reflection on spherical mirrors.